This is SpaceTime Series 28, Episode 108, for broadcast on the 8th of September 2025. Coming up on SpaceTime, the discovery of asteroid remnants trapped in the Martian interior, finding the Mother's Day meteorite, and astronomers trace superfast electrons back to the Sun. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has concluded that asteroids which impacted Mars early in its history now lie scattered in giant lumps in the red planet's mantle. The findings, reported in the journal Science, are offering astronomers new clues about the Martian interior and its ancient past. Scientists say what appear to be fragments from the aftermath of massive impacts on Mars some 4.5 billion years ago have been detected deep below the red planet's surface. The discovery was made thanks to data from NASA's now retired Mars InSight lander, which recorded the findings before the mission came to an end in 2022. These ancient impacts released enough energy to melt continent-sized chunks of the early Martian crust and mantle into vast magma oceans, simultaneously injecting both impactor fragments and Martian debris deep into the planet's interior. There's no way of knowing exactly what struck Mars. Astronomers do know that the early solar system was filled with a range of different rocky objects that could have impacted the red planet, including some so large they were effectively protoplanets. After all, it was a Mars-sized protoplanet which slammed into the early proto-Earth, eventually giving us the Moon. On Mars, the remains of these impacts still exist in the form of lumps up to 4 kilometres wide, which are scattered throughout the Martian mantle. They offer a preserved record only on worlds like Mars, whose lack of tectonic plates has kept their interior from being churned up the way Earth's mantle has through convection. The study's lead author, Christantos Karlambos from Imperial College London, says scientists have never seen the inside of a planet in such fine detail and clarity before. It's showing a mantle studded with ancient fragments. Their survival to this day tells scientists that the Martian mantle has evolved sluggishly over the last 4.5 billion years. On Earth, features like these have been erased through plate tectonics. NASA's Mars InSight lander placed its first seismometer on the red planet's surface in 2018. The extremely sensitive instrument recorded some 1,319 Marsquakes before the lander's mission came to an end in 2022 as Martian dust storms blanketed the spacecraft's solar panels, preventing it from recharging its batteries. Quakes, be they Earth, Mars, or anywhere for that matter, produce seismic waves that change as they pass through different kinds of material. And that provides scientists with a way to study the interiors of planetary bodies. The InSight team were able to use these readings to measure the size, depth and composition not just of the Martian crust and mantle, but even the planet's core. The latest discovery regarding the mantle's composition suggests just how much is still waiting to be discovered within InSight's data. Scientists knew that Mars was a sort of time capsule, bearing records of its early formation. But they didn't anticipate just how clearly they'd be able to see that through the InSight data. It's all because Mars lacks the tectonic plates that produce the tremblers many people in seismically active areas are familiar with. But there are two different types of quakes on Earth that also occur on Mars. Those caused by rocks cracking under heat and pressure, and those caused by meteorite impacts. Meteorite impacts on Mars produce high-frequency seismic waves, waves that travel from the crust deep into the planet's mantle. Located beneath the planet's hard crust, the Martian mantle can be as much as 1,550 kilometres thick and is made up of solid rock that can reach temperatures as high as 1,500 degrees Celsius. The new research identified 8 Marsquakes whose seismic waves contained strong, high-frequency energy that reached deep into the mantle, where their seismic waves were distinctly altered. When scientists first saw this in the quake data, they thought the slowdowns were happening because of the Martian crust. But then they noticed that the further seismic waves travelled through the mantle, the more these high-frequency signals were being delayed. Using planet-wide computer simulations, the authors saw that the slowing down and scrambling happened only when the signals were passing through small, localised regions within the mantle. They also determined that these regions appear to be lumps of material with a different composition to that in the surrounding mantle. With one riddle solved, the authors then focused on another, exactly how the lumps could have gotten there. Turning back the clock, they concluded the lumps likely arrived as giant asteroids or other rocky material that struck Mars during the early solar system's formation, generating oceans of magma as they drove deep into the mantle, and bringing with them fragments of the Martian crust and mantle. The authors liken the patterns to shattered glass, a few large shards with many smaller fragments. And the pattern is consistent with a large release of energy that scattered many fragments of material throughout the mantle. It also fits in well with current thinking that in the early solar system, asteroids and other planetary bodies regularly bombarded young planets. It's all part of the accretion theory of how planets are formed. On Earth, the crust and uppermost part of the mantle is continuously being recycled by plate tectonics, pushing a plate's edge into the hot interior where, through convection, hotter, less dense material rises and cooler, denser material sinks. Mars, by contrast, lacks plate tectonics, so its interior would circulate far more sluggishly. The authors say the very fact that such fine structures are still visible today shows that Mars hasn't undergone the vigorous churning that would have smoothed out these lumps, and in that way, Mars could be pointing to what may be lurking beneath the surface of other rocky planets that lack plate tectonics, planets like Venus and Mercury. This is SpaceTime. Still to come, discovering the Mother's Day meteorite, and astronomers trace superfast electrons back to the Sun. All that and more still to come on SpaceTime. Scientists have recovered samples of a dazzling meteor which lit up the Western Australian skies on Mother's Day. Researchers from Curtin University used the Desert Fireball Network, together with weather modelling, to pinpoint where the space rock would have landed and determine what direction it may have originated from. They tracked the meteor to the Western Australian wheat belt and to the remote salt flats of Lake Hope, some 530 kilometres east of Perth. So, scientists organised an expedition to search for remnants of the meteor. The journey included hundreds of kilometres behind the wheel, hours of off-road four-wheel driving, and a night spent camping under stars. A final 7-kilometre trek by foot across Lake Hope finally brought the researchers to the impact site. That's where Desert Fireball Network team member Maya Walker made the big discovery, the impact clearly visible on the stark white flats of the Salt Lake. Meteorites such as this are valuable for scientists because it allows them to match the rock type to its origins in the solar system by calculating the impacting orbit. There are only about 60 meteorites globally that scientists have orbital information on, and this is just the 10th in Australia to be tracked and recovered by the Desert Fireball Network. The team are now analysing the samples to determine their composition. Preliminary indications from the measurements made by Monash University indicate the rock is an LL ordinary chondrite, and that's similar to the Chelyabinsk meteor. That's the one which airburst over the southern Urals in Russia back in February 2013, generating a shockwave that caused more than $50 million in damage, and also let the rest of the world know just how many Russians use dashcams. The Desert Fireball Network is supported by the Curtin University node of the International Centre for Radio Astronomy Research. It uses an array of cameras spread across the country to search for meteors entering Earth's atmosphere, and then allows scientists to triangulate where they landed and where to search for meteorites. Nick Timms from Curtin University says the Mother's Day meteorite was a spectacular discovery.
So as part of the Desert Fireball Network, which has cameras stationed out across the southern Australian region in the desert, they captured a fireball which streaked across the sky in the wheat belt of Western Australia on Mother's Day. And the team identified a search region where we think the fireball ended up eventually dropping a meteorite or a bunch of meteorites. And so the team went out to explore to see if they could find these meteorites via airplane, and had a look because the region had lots of salt lakes, and it's easy to spot something that's splashed into a salt lake recently because it makes a mark that you can see from the air. Otherwise, it's searching via the bush. And so the team went out, and because they'd published the search area, there was an amateur collector who was also out on the same day who was walking towards a big splash in the salt lake, and they saw him basically collect the meteorite from the salt lake, and he saw them flying around looking for marks on the salt lake too. So it was a really good kind of public collaboration and outreach to find this find the meteorite that was dropped by the fireball. And since then, we've been analyzing that in the lab, and pieces of it have been sent for basically X-ray tomography, so we can see what's inside the meteorite before even cutting it up. And then fragments have been sent to different labs to test around the world, so we can figure out exactly how long it spent in space and how much exposure it had to cosmic rays, to figure out what kind of meteorite it is and what its history is, how we can fingerprint exactly the type based on geochemistry and isotopes, and also look at see how it's been affected over the time by things like impacts or alteration as well. So the team actually collected many fragments of this meteorite that were dropped on the salt lakes, and work is in progress. So watch this space. I'm sure we'll be able to tell you what some of the results are in the near future. Landing on the salt lake, it's incredibly voracious in terms of the chemical environment. It's very reactive. Meteorites react to water specifically quite readily. So the idea is to collect the rocks before they can be altered by the Earth's hydrosphere or atmosphere or sitting on the ground too long. And they were able to collect the samples in this particular case within, it must have been on the time frame of a week, right from calculating from the fireball where it dropped to getting people out on the ground searching. So it was really short time frame. So we were able to collect things really quickly. And fortunately, the salt hadn't really reacted and water hadn't really reacted with the meteorite much at all. So we got it while it's fresh, and so we don't have to interpret through any alteration that's gone on in the meteorite while it's been on the ground.
That expedition coincided with a meteorite conference being held at Curtin. Tell us about it.
Yeah, absolutely. Just a month or so after the meteorite landed, we were already in line to host one of the largest conferences in the world, an international conference for meteorite experts. And we were able to show some really early results to the academics around the world in terms of meteorites. And everyone was very excited to see how we can go from seeing a fireball streaking across the sky to getting some really good results from the laboratory really quickly. So they were very intrigued to see some of the new results that we haven't released to the public yet, but all will be revealed in time.
That's Associate Professor Nick Timms from Curtin University. And this is SpaceTime. Still to come, astronomers trace superfast electrons back to the sun. And later in the science report, meteorologists say there's now a 55% chance of the Earth being subjected to another La Nina climate event sometime between now and November. All that and more still to come on SpaceTime. Astronomers have uncovered two separate origins for energetic particles being flung into space from the Sun. The new findings, reported in the journal Astronomy and Astrophysics, help solve a long-standing mystery. The results are based on observations by the European Space Agency's Solar Orbiter mission. The Sun is the most energetic particle accelerator in the solar system, and it's constantly flinging high-energy particles, including protons, electrons, helium nuclei and magnetic field, at nearly the speed of light out into the solar system. This solar wind, as it's called, constantly streams out of the Sun, and it bombards the Earth. Occasionally, powerful eruptions on the Sun increase the flux of these flows, flooding space with so-called solar energetic electrons. And researchers have now used the Solar Orbiter spacecraft to pinpoint the source of these energetic electrons and trace them back to what's actually happening on the Sun itself. They found there are actually two kinds of solar energetic electrons, and they each have very distinct origins. One group are connected with intense solar flare activity. Solar flares are energetic explosions on the Sun's surface caused by the twisting and snapping of magnetic field lines, which extend from deep below the Sun's surface out into space through sunspots. The other group are generated by larger eruptions of solar plasma known as coronal mass ejections, which themselves are triggered by solar flares. The study's lead author, Alexander Warmuth from the Leibniz Institute of Astrophysics in Potsdam, Germany, says the data shows a clear split between impulsive particle events, where these energetic electrons speed off the sun's surface in bursts through solar flares, and more gradual ones, associated with more extended coronal mass ejections, which release a broader swell of particles over a much longer period of time. While astronomers had a pretty good inkling that two types of solar energetic particle events existed, Solar Orbiter was able to measure a large number of events and look far closer to the Sun than other missions in order to reveal how they form and leave the surface of our local star. Warmuth says astronomers were only able to identify and understand these two groups by observing hundreds of events at different distances from the Sun with multiple measurements, something only Solar Orbiter can do. By going so close to the Sun, astronomers could measure the particles in a pristine early state and thus accurately determine the time and place they started their journey from. The authors detected the solar energetic electron events at different distances from the Sun. This let them study how the electrons behave as they travel through the solar system, answering a lingering question about these energetic particles. See, when they spot a solar flare or coronal mass ejection, there's often an apparent lag between what's seen taking place at the Sun and the release of energetic electrons in space. In extreme cases, the particles seem to take hours to escape, which raises the interesting question, why? Well, it turns out that this is at least partly related to how the electrons are travelling through space. See, as they're flung out, they encounter turbulence, they get scattered in different directions, and so are not detected immediately. These effects build up as you move further and further from the Sun. So you need to remember, the space between the Sun and the planets in the solar system isn't empty. The solar wind of charged particles streams out from the Sun consistently, dragging the Sun's magnetic field with it, and it influences how the energetic electrons are travelling. Instead of moving in straight lines, they're confined, they're scattered, and they're disturbed by the solar wind and its magnetism. The study displays an important goal of Solar Orbiter, that is, to continuously monitor the Sun and its surroundings to trace ejected particles back to their source. These findings are important for science's understanding of space weather, where accurate forecasting is essential to keep spacecraft safe. Of the two kinds of solar energetic electrons, the ones associated with coronal mass ejections are more important for space weather forecasting because they tend to hold more high-energy particles, and so threaten far more damage. So, being able to distinguish between the two types of energetic electrons is highly relevant for space weather forecasting. And that helps with keeping satellites operational, maintaining communications and navigation systems, keeping astronauts safe in space from high doses of radiation, and helping to prepare for blackouts which could be caused by geomagnetic storms. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The World Meteorological Organization says there's a 55% chance of a La Niña climate pattern event developing sometime between now and November. Much of the Pacific Ocean oscillates between La Niña and El Niño climatic patterns, bringing cooler, wetter, or alternatively hotter, dry conditions to much of Australia. Since March, conditions have remained fairly neutral, and the World Meteorological Organization says there's a 45% chance they'll remain that way for at least the next 3 months. It also means there's very little chance of an El Niño developing. Of course, La Niña and El Niño are just two of the many climatic patterns that influence temperatures. However, it's likely temperatures will remain above average for much of the world, even if another La Niña does develop. A new study is warning that global methane emissions are continuing to increase steadily with no signs of slowing down. The findings, reported in the journal Nature Communications, indicate Asia and the developing Pacific region have now emerged as the largest contributors to global methane emissions. That's important because methane's actually contributed about 30% to global warming since pre-industrial times. To reach their conclusions, the authors looked at emissions across 164 countries and 120 sectors between 1990 and 2023. It's important to remember that methane has global warming potential 80 times greater than that of carbon dioxide. But the authors point out that methane also has a fairly short atmospheric lifespan. That means reductions today can have an immediate impact. Between 1998 and 2023, global average methane emission coefficients dropped by nearly 67%, reflecting significant technological progress. A new study has found a link between scrolling while sitting on the toilet and an increased risk of developing hemorrhoids. The findings, reported in the journal PLOS One, surveyed 125 adults, finding those who take their phone to the dunny spend significantly more time there, and also just happen to be 46% more likely to have hemorrhoids. And that habit may be more widespread than you realise. Some 2/3 of those surveyed admitted to being loose scrollers. There were fresh warnings today after it was discovered that Amazon is selling a range of pseudoscientific books promoting bleach as a treatment for autism. Now, despite the clear dangers of such a practice, Amazon have once again put profits ahead of public safety, only taking one of the books off the shelves. Tim Mendham from Australian Skeptics says a petition's now been launched to try and pressure Amazon to act more responsibly.
There is no cure for autism. Autism is a mental condition and it's prevalent in various levels of strength through most of the population. To suggest it is a condition that needs treating, that needs curing, upsets a lot of the autistic people. And to say that bleach, and we're talking about sort of industrial bleaches here, used as an enema or an oral solution to treat and perhaps purge autism out of the body, despite the fact that it's dangerous, is also a serious issue. It's a product being sold as miracle mineral solution, which is off to a bad start. It was actually being sold by a few sort of fringe religious groups at one stage. It probably still is. It's been condemned by health authorities because it can cause severe vomiting, severe diarrhea, life-threatening low blood pressure from dehydration and acute liver failure. It is not something you put inside your body, and it's certainly not something you put inside your body to cure something that can't be cured. But Amazon is selling a lot of books on this stuff. At least it's got a lot of books in its catalogue, and over about 30 of them are claiming to cure autism in one way or another. So there's a campaign to get these books removed off Amazon, and I think they've had one of them removed so far, but I think Amazon is seeing it as sort of they'll sell anything. Doesn't matter how awful it is.
Jeff Bezos needs to pay for his wedding, doesn't he?
That's right, yeah. We need the money to pay for the Venice venue. Big deal. But I mean, he's making money out of this. I don't know how well these books sell. Certainly from the early days of COVID, when it was also being promoted to cure or treat COVID, and the health people said, no, don't. And the bleach industry said, no, don't. Right? It can kill you.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.